So if you're going to properly test for a regional effect, then what you have to do is use a chi-squared test to test between these two different models. The first model, AB1, where the average score is constant, but there is some correlation caused by repeat measurements from the same hotel, and AB2, where there is now a regional fixed effect alongside this correlation caused by repeat measurements from the same hotel. Okay, and what you have to do here is to run a chi-squared test, and the command to do this is ANOVA. It's slightly confusing because, as stated there, the chi-squared test that you run doesn't necessarily obviously match with the ANOVA command that you need in R. So in R, how you do this is ANOVA AB1 AB2. So this is, in terms of the syntax, ANOVA applied to the first model and then the second model, and then it will run a chi-squared test, and in this case what you have is the p-value right at the end is 6.141 times 10 to the minus 7, which is less than 0.05. So it says there at the bottom of the slide, results give significant evidence p equals 6.141 times 10 to the minus 7 of a regional effect. Okay, so this test does give you formal evidence now that there is definitely a regional effect in this data. So in terms of presenting the results in R, then what you have is that although it's a more complicated model, R works in exactly the same way as before. So the first step that you do is you run a computational calculation, and then the second step is you explicitly ask R to show you the results. Okay, so R is like talking to a robot. Again, as I tried to say in previous lectures, think R equals robot. Simultaneously, very clever and very stupid. It will do exactly what you tell it to do, nothing more, nothing less. So in the first instance, what you have to do here is get it to run a model, here a linear mixed effects model, and then in the second step, get it to show you the results. And in order to do this, you use the summary command as before. Now, the trick when you were looking at regression results in R is to just pick out the useful information that from the output, and that's exactly what you have to do here. But the problem is now that because this is a more complicated model, you have to be even more judicious in terms of the useful things to pick out of this data. And really, I think the things to look at here would be the fixed effects terms, which will give you the interpretation in terms of the average score for people from each region once you've corrected for correlations in the data caused by repeat measurements from the same hotel. So how this would work then, so the second linear mixed effects model with the regional effects is the model AB2. So in this case you would just do summary AB2, and then the things to look at here would be the fixed effects terms. So this will give you the regression terms that correspond to the fixed regional terms once you account for correlations caused by repeat measurements from the same hotel. Exactly as before, really the action here is from the second row downwards. Unfortunately, some of the data display is a little bit more confusing compared to what you've seen before. Unfortunately here, when the t statistics are calculated, it doesn't give you the p-values. So the thing to watch for here would be to look at the t-values and then look at the t-values for which the absolute value of the t-statistic in the last column is bigger than 2.0. Okay, so if you look at the last column and take the absolute value, the only one of these that is bigger than 2 once you take the absolute value is the London Essex region. So the t-value in this case, once you take the absolute value, would be 4.304, which is bigger than 2, so it's this one that's significant. And if you look at the left hand side, the estimate is minus 0.119061, so the coefficient of the London Essex region is both statistically significant and negative. So some artificial differences in terms of how the results are presented, okay, but most of the interpretation and calculations work the same way as before, though this time the results should be more robust, precisely because you've accounted for correlations caused by repeat measurements from the same hotel. So in this case, what you have is evidence of a London effect. Now the easiest way to write this down would be that the t-value is 4.304, which is bigger than 2.0, so the p-value is less than 0.05. And then in contrast, if you look at the other regions, there's no evidence of an effect. So for example, for the Scotland region, the t-value is 1.855, which is less than 2, so the p-value is bigger than 0.05. And again, I just wanted to articulate here this little trick. So the t-value is less than the critical value in the second case, so the p-value is bigger than 0.05. Again, if you've done this right, the inequality signs point in a different way. And then for the first example, because the t-value is bigger than the critical value 2.0, then this must mean that the p-value in this case is less than 0.05. And then the interpretation will be much the same as we've seen before. So the London term is negative and statistically significant. This is the cleanest way of writing this down, remember, although it's the opposite way around to how we work it out. And this reaffirms the previous suggestion that London companies may be at a disadvantage. So in terms then of how to adjust survey scores out of 5 for the regional bias, so for the East Midlands region, the average score would just be the intercept term. Then for the London region, what you have is the intercept term minus the adjustment to give you the average score. And then for the North East Yorkshire region, the intercept minus this adjustment here of 0.003653. For the Northwest, it's the intercept, and then in this case plus the adjustment factor 0.005216, and for Scotland, the intercept plus the adjustment factor here of 0.057297. Now, if you're wondering where these adjustment factors come from, they are precisely from the estimates of the results on slide 5.9. Okay, so there's two things really to watch for here. So the first thing should be that these scores are all the similar order of magnitude, so there's no immediately obvious indication that you've made a clear mistake here. And the second thing to watch for is that the London score is less than the other regions, and again this is going to reaffirm what we had earlier, that the coefficient for the London region was significant and negative. So this set of results here gives you extra practice in how to interpret the results in slide 5.9. So for the south, the score here, the average score here for people from this region would be the intercept minus the adjustment factor here of 0.014028. This is from the slide 5.9. For the southwest, again the same slide here. The average score for this region would be the intercept plus the adjustment factor here of 0.008482. For Wales, the average score for this region would be the intercept plus the adjustment factor here of 0.014557. And for the West Midlands here, the average score from this region would be the intercept plus the adjustment factor of 0.016191. Okay, again, one thing to watch for here is that these results are all of this similar order of magnitude, so there's no obvious mistake that we've made here. They are fairly similar. These results aren't significantly different from each other. Remember, the only difference that we found to be significant was the difference between London and the rest of the UK. So the main thing here to watch for is that all these scores are roughly the same order of magnitude. So now I wanted to go on to a professional standard analysis of problem 2 in R. So this does get more complicated, okay, but should be a repetition of some of the things you've seen before, especially in the last lecture. So it turns out that the basic R command you need is glm-m-pql in the R package mass. Okay, essentially what you end up with is a repetition of the logistic regression models of the previous lecture, and there is a further adjustment, exactly as we've seen in the previous section, to account for the repeated measurements from individual hotels that we have. So the structure of the data set is such that we've got some correlations caused by repeat measurements from the same hotel, and we need to make an adjustment for this using these generalized linear mixed models. Okay, and again, lots of the R commands here have a sort of mathematical and statistical backstory. You don't need to know the backstory, but I think it makes it easier to figure out what's going on here, because the backstory means that the R code is deliberately named, and here the R command you need, GLMMPQL, stands for Generalized Linear Mixed Models fitted via Penalized Quasi-Likelihood. So that's what the PQL bit stands for, Penalized Quasi-Likelihood. It's just a numerical computational routine performed in R. So very similar to what we've seen before then, we've got these three basic problems. We want to quantify if there is a regional effect in the probability of giving a high score. Secondly, we want to quantify if there is a regional effect in the probability of giving a low score. And again, as a formal check, even though this should technically be a redundant step, we want to quantify any regional effect in the probability of giving a medium score. So what we're doing here with these generalized linear mixed models is necessarily a lot of repetition compared to the generalized linear models that we were looking at before, but the mixed bit, remember, is a big word in statistics and is needed here precisely because we need to take into account the correlations that occur and that are caused by the fact that we've got repeat measurements from the same hotel. Okay, and then in order to answer these questions with a professional standard analysis, we need to use these generalized linear mixed models precisely because we need to take into account the correlation that is caused by the structure of the data set. Okay, now if we do this and we have a more professional analysis, one of the things to sort of watch for here is that you should hopefully get a clearer answer to each of these three questions. Okay, and the results should be clear and easy to interpret if you've got the analysis. So for this first problem then, testing for regional effects in the probability of giving a high score, what you should see here is the same rhyme, rhythm and reason in terms of the R commands that we've seen before. So the first step, compute the model. The second step, show the results using the command summary, because again, think R for robot. R is simultaneously very clever and very stupid. It will do exactly what you tell it to do, nothing more, nothing less. So the first step, compute the model, and in the second step you should summarize the results. Okay, you need to explicitly say summary of the object in question in order to get it to explicitly display the results that you've calculated. So my apologies here, that should say summary rather than summary. Step 2. Step 1, I just wanted to try here to show you how these things are working. So I've tried to call it high 2 just to give it a logical name. This is a generalized linear mixed model fitted by generalized quasi-likelihood, rating high region. The random term, the extra correlation structure, is some correlation caused by repeat measurements from the same hotel. This is what this bit here means, tilde one given product, and then equals binomial. Just to emphasize here that we're trying to fit a probability regression model, not a straightforward regression model. So I just wanted to say something here about the R commands and the structure of the model. So generalized linear mixed models are the harder version of generalized linear models. The mixed bit is quite a big word in statistics. It just means there's some extra correlations you have to take account for due to the structure of the sample. Here we've got repeat measurements from the same hotels. Now the thing to watch for here is that the similarities in terms of the statistical interpretation and the R commands of the model. So as we've seen before, this, if you look back at the R commands on the previous slide, this random equals tilde one given product just reflects you've got the same correlation structure as the linear mixed models discussed previously. So essentially you've just got some correlation here caused by the fact you've got repeat measurements from the same hotel. You need the family equals binomial bit here to specify that you've got essentially probability regression models rather than just a straightforward linear regression model. Okay, and this is exactly the same as was the case with logit and probit models, and you can do logit and probit versions of the same generalized linear mixed models. The numerical examples work almost exactly the same way as the logistic regression and the probit regression methods you'd seen previously. It's just that these things here that you need to focus on are the fixed effects terms.